Hey all, in this video we're looking at linear equations and solving them. So we'll start with looking at what solutions to linear equations look like and don't look like. So for this first example, we're given this equation and asked to see if this is a solution. So we'll put it in for the x, and then if it comes up true, then it's a solution. If it comes up false, it's not. So this is going to look like 3, toss a negative 4 in there, plus 2 equals negative 8. I could distribute, or I could also just combine these, which I think seems easier. And I get negative 6 equals negative 8, which it does not, so that means no, this is not a solution to that equation. Same thing over here with a 5, so we're going to put the 5 in for the x. Now look like 3 and then times 5 minus 4 equals 2 times 5 plus 1. And just cleaning this up a little bit, I get 15 minus 4, 10 plus 1, and that is 11 equals 11. So when I put in the 5, I get the same thing on both sides. So that would be, yes, that one is a solution to the equation. The rest of the section is solving linear equations. And so there's some steps in kind of an order to do these things in. First thing is if there's parentheses, you want to clear those. If there's fractions, it's very often a good thing to clear those. We'll show you some examples, and we'll see that all throughout this chapter. This third step is the one where people tend to not do it, and then it screws them up on the fourth step. So the third step is collect the terms on each side of the equal sign. And I have my sarcastic, really, do this, because really you should do this. And that's like over on this side, you can see I'm going to run this x through when I clear the parentheses, or the 2 through, pardon me. And then what I want to do is combine these terms before I start moving stuff around on the equal sign, because it's the moving is where everyone makes all the mistakes. So if you make it as easy as you can, as simple as you can, cut down on your errors. And I'll show a bunch of examples with it. Fourth step after we collect is the adding and subtracting that I was talking about. And the fifth step is to that last thing where you isolate the x. We're going to end up using the multiplication property where we multiply or divide both sides to isolate. So let me show all that with a bunch of examples. It'll make more sense. This first one, so we got 3200x plus 60 equals 0. The goal is to get that x by itself, and so I have no parentheses, I have no fractions, and this is pretty simple. There's nothing to collect. I don't have like terms. So I might use the addition property. So for this, I have a plus 60 there. So to undo addition, I want to subtract. So I'll subtract 60 on both sides, and then that makes 3200x equals negative 60. And then use the multiplication property to get 1x. So to undo multiply, we divide, and vice versa. So we'll go ahead and go 3200, and those cancel, so there's my 1x. Here I can knock out a power of 10, so I'll just cancel those zeros. So now I'm down to negative 6 over 320. But those are both even numbers, so that means I can go a little bit more here. So I'll write this as negative 2 times 3. And let's see, that'd be 160. So 2 times 160. Knock out those 2's, and we got x equals negative 3 over 160. And when you put this in the computer, put in the fraction. If you change that to a decimal, you end up rounding and the computer will mark you wrong. So even if you get a crazy fraction like that, just put that answer in as is. Let's see, this equation over here, we have parentheses this time, so I'm going to go ahead and do a little distribute. So that would be 8x plus 2x minus 4 plus 6 equals 10. And then here's where I got these like terms. So I have, and this is the collect the terms on each side of the equal sign. So 8x plus 2x, I can combine those and make a 10x. Minus 4 plus 6, I can combine those and make a plus 2. And now this side looks a lot easier, and it's a lot cleaner to see what I have to do for steps 4 and 5. So addition properties, so I'd undo addition with a subtraction. So I bring the 2 over. And then multiplication property, so that gets us over 10. These cancel. And then this would be 2 times 4 and 2 times 5. So I can knock out the 2's, and x should be 4/5. You gotta do a little distribute. So that's gonna be 6 minus 3 times 2x. That's gonna give us minus 6x. Right here is where lots of errors happen. Watch those two signs. Make sure you get a plus there, and then 15. But a lot of times on that second distribute, people either mess up the sign or forget to do that piece altogether. And then over here we got a 13 minus 5x. And so then I'll go ahead and collect my like terms before I start moving stuff around. So I could write in either order, but I like the x's first. We'll go descending order. And then 6 here, 15 here, so I'll put those together and get a 21. And 13 minus 5x on that side. So now I want x's to one side and numbers to the other. So that's going to be, and it doesn't matter, I can bring the x's either way. So this time I'll go ahead and bring it this way just to show what to do with the negative x. Also, if you've done a bit of algebra as of late, you're welcome to do the 21 at the same time. I'm going to show just 2 separate steps, just sort of assuming people haven't done this for a while, so I'm trying to kind of break it down into smaller steps. But do feel free to jump if you're more comfortable with this. So negative x plus 21 equals 13, and then those canceled. So we got our x's on one side. Now I'm going to bring this 21 over. That's going to get us negative x equals 7 and 1, so it'd be negative 8. So if negative x equals negative 8, then that means the positive x would equal positive 8. And you can get that just by multiplying both sides by negative 1. So if you end up with a negative x, just reverse the sign on both sides. So if I had negative x equals positive 8, then I'd have x equals negative 8. Same as multiplying by negative 1. This one, okay, so this is the one with the fractions, and this is this little thing I'm going to show you here. We'll see it in this section, and we're going to see it all over the end of the chapter 2 and all over math pretty much. This is this little trick that we can use to clear fractions. I could do this problem where I bring the x's to one side, fractions to the other, and then do like a lot of kind of crummy math to try to put all those fractions together. Or I could just kill off all the fractions pretty much in the first step. So I'm going to go with the killing off the fractions thing. Really encourage you to learn this technique. Very, very handy. Shows up a lot. So what we do is we go 3, 12, 4, and 2. We look at all the denominators and we go, what's our LCD? So for everything, the LCD would be 12. So I'm going to multiply everything by 12. And what that will look like, I'm going to write it as 12 over 1. I'm going to draw through my 6 there. Just to emphasize that the numerators aren't changing, so we're multiplying the the numerators are changing, it's the denominators aren't changing. They're just getting multiplied by 1. And eventually you want to get where you skip the step I'm about to write, but when you're first learning this, this step is really helpful for kind of seeing the canceling that happens. But if you just taking this first one, if you look at this and go, hey, 3 is going to go into 12 4 times, this is going to be a negative 4. That's awesome. That's where you want to get to. I'm going to break it down into a little bit smaller bites, just assuming people have not seen this before. So negative right there, and then 12 times 1 will be a 12. 1 times 3 will be a 3. And then plus 12 times 5 is 60. 1 times 12, 12. And x, or equals, is under there. So 12 over 4. And then 12 times that 1, 12 over 2x. Okay, so the reason we want to use this LCD is because now all of our denominators are going to divide in evenly, and that won't have fractions. So this makes negative 4. And notice right here I could go 3 into 12 makes negative 4, so you can jump right to here if you're comfortable. Here you could look at it and think, okay, the 12's cancel, I'm going to have a 5x, which is exactly what this is showing. 60 divided by 12 will give you 5. 12 over 4, right there, that's 3. Here, 12 over 2, we could think of as canceling, get 6x. That's exactly what this is showing. So write this for as long as it's helpful, but once you get to where you can jump from here to here, it's a really handy little technique. It makes things much easier. So just since I solved this one with the negative x, I'll go this time for a positive. And there's no rule that says I have to solve the x to the left. So I'll just go ahead and solve this one over to the right, just to show that you can. So -4, those cancel, equal 3. 6 minus 5 would leave me at x, or you can think of it as 1x. And I'll just scoot that 3 over. And I got -7 equals x. And which is, of course, the same thing as x equals -7. So it doesn't matter which direction I solve. Cool. So that's a tough problem, but I do really encourage you to kind of make friends with this technique and see if you can get where you can jump from here to here on it, because that will be so handy for you in future sections, like right at the end of this chapter, actually. Okay, these next 4 questions with the highlights, these are the ones that if we're in a lecture class, I would have the students try in groups. So they're going to be fairly similar to the ones I just did, but a couple extra examples, and you're welcome to pause the video and try them for yourself. So this one's kind of funny. So I got this plus with the parentheses. And these parentheses aren't doing anything. And sometimes you do something where you substitute in and you have these parentheses with a plus in front. And they're just really kind of for show. They're not really mathematically meaningful. So we'll just drop those out of there. And then I'll do my collect terms. So I got 3x and 4x there for 7x. Down 1, down 3, so that's down 4 equals -33. And then we're at our add subtract step. So I'm going to add the 4 over. So that gets us 7x. Those cancel. What is that? -29. And then divide out the 7. And x is a rather unreassuring -29/7. So then number 8, this time the parentheses are doing something. So when it's a plus, we don't care. But with that minus, that's acting like a little -1 right there. So we're going to have to distribute that sign through the parentheses. So I'll start with my 5x. -1 times 2 is going to, or -2x is going to make -2x. -1 times -6 is going to make a +6. So notice this negative in front, it just changes the sign on everything in the parentheses. So you can just think of it as minus plus. And then that +6 on the end, 6x equals 4. And all kinds of like terms. So we got 5 minus 2 would be 3, and then back up 6 would be 9x. Plus that 6 in there makes 4. And then we'll bring our 6 over. Try to get our x by itself, so we're always trying to strip everything off of x. And we can divide the 9. And there's our x equals -2/9. Okay, so this one, we've got some distributes, so we're going to go ahead and run that through, and then we'll run the -2 through. So this is going to give us 4x, 4 times 5 for 20, minus 2 times x for -2x. There's that little double negative again, so plus 12 right there, equals -7. And then for our like terms, we got 4x minus 2x, so that will be 2x, 20 plus 12, so that's plus 32 equals -7. Some more unreassuring numbers. So that's going to go -32, or -32, sorry. So 2x, that's gone, equals -39. And then we can just divide the 2 over. And then there's our fraction problem. So this time, let's see, our LCD, we got 2's, 8's, and 4's. And so you gotta be careful to grab the LCD for everything. Sometimes you'll see people do one side by 8, one side by 4, which is not so legit because you gotta multiply both sides by the same side thing or it's no longer equal. So we will do a 8/1 and 8 over 1. And again, I'm going to write out that big step here, but if you're comfortable jumping to the next line, definitely do that. This is just to help you see the canceling. So we're going to have 8 over 2, just multiplying straight across, minus 8 times 5 would be 40 over 8. There's our x. 8 over 4, 24 over 4, and then x. So notice none of those denominators are changing, right? Because they're all just being multiplied by 1. So the only thing getting affected is the numerator. And then here's that cancel step. Again, if you can do it right out of the gate, do that. But here we're at 4 minus 40 over 8. That'd be 5x. 8 over 4, that's going to be 2. 6x there. So I think I'll solve for positive x. So I'm just going to bring this 5 over. I got 4 equals, cancels, 2 plus 11x. And then I'll take the 2 over. That'll be 2 equals 11x. And then just divide out that 11. And so x equals 2/11. Okay, these last 4 examples are of kind of the funky things that can happen when you're solving linear equations. There's a version where you can get no solution, where they just basically took 2 things that are not equal to each other, set them equal to each other anyhow, and then you go solving it and it doesn't turn out. So that's a no solution. We'll see in chapter 3 that the geometry behind that is that we actually have parallel lines, and so they never cross, so there's no answer. Infinite solutions is when they put 2 things that are actually the exact same thing equal, and so then everything's going to work because, if you look at it, x plus 5 equals x plus 5. Any number I put in there, it's going to make it equal. So let me show math-wise what that would look like when you're solving. So over on this side, if I went to just sort of get the x's to one side bit, I could subtract the x over, but then these cancel and I'm left with 5 equals 7. Well, 5 does not equal 7, so this is why it's a no solution, because I'm getting this false statement down here. On this side though, when I bring the x over, I get x is canceling, but I got 5 equals 5. So that one's a true statement. And so when you get the weird true statement, that's where it's actually infinite solutions. So the false ones, no solutions, true ones, infinite solutions. For what that would look like in the course of kind of a bigger problem. So we've seen a few things like this. We'll do our little distribute, clear our parentheses out of here. So this is going to go 7x, 7 times 2 for 14, negative 4 times 2 for negative 8x, negative for positive 4, equals 18 and minus x. And then we collect our terms. So that's going to be negative x. 14 plus 4 is plus 18 equals 18 minus 18. So then here we try to bring our x's to one side, and it seemed like everything was cool, and then the x's drop out. So now we got 18 equals 18. So that's a true statement. 18 does equal 18. And so the true ones are the kind that have an infinite number of solutions. So infinite solutions. So this last one, you can kind of guess what that's going to be. I got a 5x minus 4x, no parentheses, so I'm just going to collect some terms here. So that leaves me x here. And then minus 3 plus 7, so that's going to be plus 4. Over on this side, I got x. 4 and 6 is going to make 10. And then when I go to try to solve for my x, everything drops out. But now this time I'm left with 4 equals 10. And so 4 does not actually equal 10, so that means this is a no solution. So true things, infinite solutions, false things, no solutions. Cool, so that wraps up linear equations.